Hello, in this video, I'd like to talk about valid arguments. Validity in logic does not have the same meaning as um, in colloquial speech. When people say that that is a valid point or something like that, what they mean is generally that they agree with the statement being made. But validity in logic has a very specific technical meaning. Uh, it refers to the structure of the argument. It refers to the fact that the argument uses correct rules of inference to establish the conclusion based on the premises. Validity in logic does not mean that the premises of an argument must be true or even the conclusion must be true. It rather states that it is impossible for the premises to be true and the conclusion to be false. So let me write that definition. So a valid argument um, is one in which it is impossible for the premises to be true and the conclusion to be false. Well, to better understand this, it is important to be able to translate a argument into a statement, into a tautology. So let's suppose we have the premises P1 and P2 and so on. Let's say we have these statements which are givens, and then we want to conclude from this C. Well, so these are called premises, and of course this is called the conclusion. Now an equivalent form to this is one where we can consider this as a statement. So for example, we can say, all right, let's put together P1 and P2 and P3, etc., in the form of a set of conjunctions. Well, rather, a whole bunch of conjunctions. And then we can say this compound statement implies the conclusion. So what's going on is that now we have the statement form, okay, of the argument. So what happens is that this argument is valid if and only if the statement is a tautology, right? So what does it mean to be a tautology? It means that its truth table has only true values. That at all rows, right? At all rows of this truth table, the final column, which represents this complex statement, contains only true values. So let me write that down, right? So the idea is that the argument, this argument is valid if and only if its equivalent statement is a tautology. Okay. So, and you can see from this point on why, in fact, a valid argument does not necessarily have to have true premises. Okay. Because if you think about this complex looking statement, let's suppose all of this, in fact, is just a complex compound statement P. And let's take a look at the truth table for this compound statement, right? So let's say we have, of course, P and we have C, and we have several possibilities. Let's write those down. So everyone's familiar, hopefully, with this truth table. So what can we say about the conditional statements P implies Q? Well, we know that P implies C. Well, we know that it's false only when the premises are true and the conclusion is false, right? All the other times, we know that, in fact, it's true. So the only time this giant statement is going to be false is when all of these premises, all the P1, P2, P3, all the way to Pn, they're all true, and the conclusion is false. That's the only time we would say it's invalid, right? So, so in other words, this particular row of the truth table indicates when the argument is going to be invalid, right? All the other times it's valid. So, for example, when all the premises, or actually any one of the premises, are false, right? You could still have a valid argument because the conditional statement is still nevertheless true, right? So in a way, it's much easier to show that an argument is invalid, right? So to show that an argument is invalid, you would show that it's possible to make this giant compound statement true while at the same time making the conclusion statement false, right? So that is a possibility. If that is a possibility, then we know that the argument is invalid, right? If that is impossible, if it's impossible to do that, then we know that the argument is actually valid. So let me give you a couple of examples of valid arguments, which may look quite weird, right? So for example, let's say we have something silly like 1 equals 1, or, okay, 1 equals 3, okay? So that is clearly a true statement. And then let's have another statement. Let's call this P1 here. And that's what we have P2. And P2, we're just going to we're going to say something silly, right? Like 1 equals 5, let's say. And then the conclusion, excuse me, I'm going to say it's not the case, right, that 1 equals 1. And then for the conclusion, of course, we would say that 1 equals 3. So you can see that this particular argument, it's quite a silly argument, but nevertheless, this argument uses the disjunctive syllogism rule of inference, right? And since it uses disjunctive syllogism as the rule of inference, it is indeed a valid argument. It's impossible for this to, for the premises to be true and the conclusion to be false. Now, in fact, the premises are not true. That's the reason why the conclusion is false, okay? Is because one of the premises is not true. In fact, P2 is false, right? So that's why this is actually a valid argument. It's impossible to make the premises true and at the same time the conclusion to be false.